Welcome back to this IE3D tutorial on antennas design. This is the second tutorial which is a follow-up of the first tutorial. The first tutorial as a revision was about the software IE3D as a whole. How does the environment look like and what all are its features and how do we start with the software. So the screen which you are able to see right now is the parameters for FR4 which I'll be using for the design. So let us start with a basic antenna design. So a basic antenna design would be obviously a patch antenna. So let us start with that. I'll quickly do the setup as you are already known. So we'll be adding one more layer. So let's name it as FR4. The substrate thickness 1.6, dielectric constant of 4.2, loss tangent of 0.008, and rest of things remain same. So we'll say OK. So things are done. The rest of the things remain as it is. We'll say OK. So our screen is ready to be started with. Okay, now whenever you make something over here in this green layer, the green layer would act as a ground layer, or not a ground layer, sorry, pardon me, it would act as a substrate layer. Okay, so let us say it has a length of since we are in so let us make a patch antenna of maybe maybe 100 by 100, that is 10 centimeter by 10 centimeter. Okay, it's a big one. Let's make something small. Let's say 9 centimeter by 9 centimeter. Yeah, that would be fine, I guess. Okay, so this is the layer. Above this will be the metal. So we'll be having a metal on the 1.6 group. So basically this 0 means the lower part, 1.6 means the top part of the dielectric substrate. So on the top part of the dielectric substrate, whatever you make, that will act as a metal layer. So metal would, let's say 50 by 50. Okay, again let me warn you that this is not as per the calculations. The main aim of this tutorial is not to teach the design of antennas, but to teach how to design antenna in IE3D. So let us take it as a length of 50 and width of 50. So it looks as if a metal layer has come towards the top end, but is it in the top end or not? You can just confirm it by looking over here. So it says 1.6, that means it's fine, right? Alright, so now we need to assign a port to it. Now a basic rule for any type of antenna is that the port should not be in the exact center, because in the center the fields cancel each other and therefore there won't be any excitation. So generally the distance of it is lambda by 4 to lambda by 2 from the center. So let us give a point. So let us say this point somewhere here. Okay, so we'll go to port, we'll say build probe feed. Now we need to give this x and y, so that's why first of all we need to make a note. Now in this point it shows the cursor position. Wherever you move the cursor, it will show you the x y points. Suppose I move it over here, I want y to be exactly 0, or maybe you can keep it little bit up, just it will give some polarization. So maybe, or okay, no problem. So we'll give it as, I think we'll give it as around -15 and 0, right? So we'll go here, we'll say build probe feeds, we'll say minus 15, y will be 0, and press enter. If you don't press enter, it will assume it as 0 0, and it will place the port exactly at the center, which we don't want. Now this number of segments of circle defines that how many segments would make it a circle. So IE3D don't have a continuous lines. So what it does is that using number of straight lines, it makes a circle or any kind of polygons. So basically you can say, in terms of the language of IE3D, a circle is made up of number of lines, or a circle is a polygon which is made up of maybe 6 or more lines. So generally we'll give it as 8, which will give a decent type of circle. Okay. Radius, I think it's fine, but you may increase it to maybe 16, because it's mm, right? So we have to give it as per mm, because 0.16 would be a very small one. Okay, so the rest of the things are fine. Okay, so we'll give it here. Oh my god, so I think it takes it as mm and not this one. So 0.16 was fine. So let us rewrite this one. Number of segments for circle 8, x as minus 15. Okay, so let's keep the radius as it is. Oh, so here's a live demonstration that if I don't press enter, it will show it exactly at the center. So let's do Control Z once again, and then go to probe feed, say minus 15, enter, say 8. Okay, so this radius would depend upon your connector. So suppose you are using SMA connector, so you need to know the specification of SMA connector and you need to give it accordingly if you want an exact result for it. So if you see here, here is our probe feed. Okay, and if you see the 3D, you will see a probe feed exactly in between. Okay, so this somehow completes our basic antenna. So what antenna contains is a patch, then there is a dielectric, and this entire surrounding is the ground, because we have still not made it a finite ground and it still is a infinite ground. All right, uh, now what all are left? We need to declare the frequency. Okay, now since we have not assigned any frequency to it, so using a general convention that a smaller length would have a higher frequency, I would give that simulation parameter over here. Okay, so before simulation is done, we have to save it. So let's save it as tut2. Okay, now we need to give its frequency, so we go to simulate. Okay, we say enter. Okay, so let's say its start frequency to be about 0.8. 0.8 means obviously 800 megahertz. 2. Okay, since we have not declared frequency, let's say it as 3. Okay, now this number of frequency defines your accuracy of result. So what generally we do is that first of all we take a lesser value of number of frequency and check whether our result is coming or whether it is aligned to what we had predicted. Then we go on increasing the number of frequency, and because as the number of frequency increases, your simulation time would increase and things like that. Okay, so we press OK, you say yes, because it want to declare messing frequency. So messing frequency is generally the highest frequency. Now since we have given just 10 points for between 800 megahertz to 3 gigahertz, obviously we won't get a very good graph, but still I just want to show you. Now while setting it, click this radiation pattern and your settings should be exactly like this. Okay, 50 ohm matched, and say OK. You need to have all your setting as per this one if you want to have a clear cut diagram. Okay, now since these all things are done, okay, so one more thing, if you say no FASTA, okay, and you say scheme as classical, and meshing alignment, you say align the polygon, okay, this one. So doing these all things, what it will do is that it will take all the frequency and not predict any frequency. All right, so I think we are done with it and we are ready to simulate the environment. Right, so let's go for it. Okay, okay, so let's see if it takes time, then I would stop, or I would pause my video, otherwise we can continue. So basically it's taking lots of time because it would now divide this entire antenna into small meshes, and then it would calculate for each and every mesh the frequencies allotted, or the frequency which we declared, and it would prepare the S11 parameter, or for the most part the Smith chart, Z parameters, VSWR, all those plots based on the calculation it did for each and every frequency component. Alright, so it's not taking much time, so I suppose it's taking 27 seconds and things, so let's wait for some time. So till it goes on, maybe I'll show you some more things. So in IE3D, not only the antenna design can be done like this, there is a part which is called as line gauge. Now this line gauge is a very beautiful tool which helps us to get the size and predictions instantly. As for example, suppose I want a 50 ohm matched microstrip line for a 1.2 gigahertz frequency, relative permittivity of 4.2, substrate height of 1.6, and thickness of 0.002, right? So if suppose I have this type of situation, oh great, our simulation is completed, so let me just complete this. Okay, so if I have this type of situation and I say I have a 50 ohm matched, and if I click this electrical to physical, then it would show that I should have a strip width of 3.1 for a length of 34 mm, right? So similarly you can design a microstrip inverted, microstrip suspended, strip line, and all those coaxial lines and all those things, and you can obviously open them or even copy it, right? So if you click open, then it takes some other data, otherwise it copies it to clipboard. Now let us see. Now as soon as your simulation is over, this type of screen appears. You need to add the graph over here, click on S parameters and then click on dB, say OK. It will add the graph over here. Then let's have a Smith chart. Okay, let's say OK, and maybe a VSWR in dB. Alright, so you need to tick all these things, say OK. Now these plots are available over here. As soon as you click close, it will show it. Okay, it's a very random data, maybe it would have come around 3 to 4 gigahertz. Okay, but okay, anyways, we are not concerned with the design of S parameter or design of microstrip antenna for the most part. If you see this is the Smith chart and this one is the VSWR. Alright, so in this way you can design a patch antenna. So just a minute, let me check whether I have any sample antenna. So I have something. Let me check if I have the result for it, then I can show you some graphs. Okay, so this is one of the graph which you can see it's coming around 1 gigahertz. I didn't simulate it after that, so it comes around 1 gigahertz or 1.1 somewhere over there. Okay, so that's it. In this way you design your antenna and you view your results. Now if you want to view some other results like 3D patterns, since we had simulated the 3D pattern, so you can look at the 3D pattern. So let me just open it. Okay, so if I want to see the 3D pattern, since the simulation was done, so the 3D pattern can be observed over here, right? And if you want to view some more parameters, then you can go to window. You can check out directivity, your gain, your effective gain, axial ratios, and all those things which will help you to understand your antenna parameters better. So I guess you understood the basic uh, procedure of designing an antenna in IE3D. In the next tutorial we would be looking at making various uh, complex designs of antennas, like making a slot, making different types of patterned antenna, for the most part like that of a Vivaldi antenna, and maybe some other type of microstrip antennas, like those of arrays, how to design arrays, how to copy them, how to reflect, and all those things will be done in our next tutorial. Till then, goodbye, take care, and yes, subscribe to my videos.